Hi everybody and welcome. Today we're going to be talking about a specific example of transversals, and this is when, again, reminder, transversal is when a line crosses two other lines, or two or more other lines I should say. So we're going to be talking about a specific example where a transversal crosses a set of parallel lines and the special situations that happens when that is the case. So your goal after watching this video should be able to describe some theorems and postulates of when a transversal crosses parallel lines. So an example of this, I had a picture way back when of my deck when I was building the stairs on my deck. This actually was something that came up. What you're going to see in this picture is that a couple examples actually of parallel lines and a couple examples of transversals. But when you're putting up the deck posts for the edges of the stairs, what I'm highlighting in yellow right now, they're both perpendicular to the ground, and if they're level, they'll be perfectly parallel. If they extended forever into the sky, they would never cross. And then you have your railing that actually cuts through them, and that would be an example of a transversal because it's cutting through two parallel lines. It's cutting through in two different places. So what happens with this is we have a special situation, and this is actually going to help you out, especially if you're trying to construct this and get good square angles here and make sure that everything is kind of in order and doesn't, look out of place or isn't kind of lopsided. We have to make sure that the angles on all of our cuts are perfect. So if we're thinking about angle D and angle A, when we're cutting that 2x4 or 2x6 or whatever you're using in the center there, we have to make sure that it aligns perfectly with the post. And if it doesn't, it's going to look weird. It's going to be kind of off, out of shape, and you're not going to have a nice square kind of mounting surface to basically make your steps, make sure that they're sturdy, make sure the railing doesn't collapse, and make sure you have a good fit and finish. So our objective today, we're going to come back to this picture at the end, is to be able to use the information that we're given, basically from this diagram and from the angle that we're given, 65 degrees here, to determine all of the other angles in this picture. And that's a big deal, and that's going to be really important for, again, this is a specific example, but when we're constructing this staircase. So today actually is a bit of a new lesson for us in that we're not going to have definitions. So we're going to be relying on things that we did last video. So if you need to click back on that at any point, definitely do that. But we're going to be relying on things we did last video, and we're going to apply those things from last video specifically to the situation where we have a parallel line, parallel lines and a transversal through, again, specifically parallel lines. So to start off, on the bottom, we're going to just mark this with this little arrow, and that's going to tell us that those two lines are parallel to each other. So if they're parallel, this is important, that changes everything. So first, the corresponding angles postulate, each pair of corresponding angles is congruent. And that just means the same. So if, again, thinking back to our corresponding angles, our corresponding angle pairs, I'm going to circle, actually I can highlight them, and I'll do them all in different colors. So 6 and 8, that's one pair of corresponding angles. They kind of match there. 7 and 1, another pair. 4 and 2, another pair. And then let's do it in blue, 3 and 5. So all of these corresponding angles are exactly equal to each other. So to summarize, we could say that like angle 1 is congruent to angle 7. Okay? And remember that squiggly line on top, that means congruent. All right, so now some new things that we can take from these. So alternate interior angles. So remember, interior angles are on the inside of the lines, and alternate means not next to each other, so we're across from each other. So let's highlight some examples of this. We'll do it in brown. So angle 7 and angle 3, that's an example of alternate interior angles. And you can kind of tell by looking at them that they look the same. And actually by this postulate, we're able to see that if it cuts through parallel lines, we can definitively say that they're congruent. So alternate interior angles, they are 100% congruent. We can say that with certainty now. And if anyone asks you why, what's your proof? Well, now we can use this theorem. We can tell them, because of this theorem, if it cuts through parallel lines, it's always going to be congruent alternate interior angles. All right, what about alternate exterior angles? So let's highlight those. So that would be like, for example, 1 is on the outside, and it's alternate angles, not 6, but 5. Those, again, they look pretty similar, and using this theorem, we can again say concretely here, they're also congruent. So those measures are going to be exactly the same. And then finally, consecutive interior angles. Okay, let's take a look at these again. Maybe I should change my highlighter color because I've used that one too many times now. So consecutive interior. So bringing it back to these, what we're going to see is that's when they are on the same side of the transversal. So for example, number 3, the only other angle that's on the interior and is below the transversal is 4. So 3 and 4. Well, again, if we just look at this, we're going to notice they actually don't look the same. 3 looks acute, 4 looks obtuse. So what's the relationship? What's this going to tell us here? Well, actually, in this case, it's going to tell us that they're supplementary. So if we put them together, they're going to add up to 180 degrees. So these are 4 key pieces of information that we're absolutely going to be relying on quite a bit going forward, solving all of the questions from today's lesson. That's why in this specific situation, we took all of our time with our definition today, just to go over, again, just a quick review of what these angles are, but also what it means if, again, 2 parallel lines are cut by a transversal. All right, so let's start off with an example. We'll go through 1 or 2, and then again, today, again, not a whole lot of new stuff, just an opportunity to practice. So in the figure, measure of angle 3 equals 110, measure of angle 12 equals 55. The first thing that we actually need to do now is before we start solving for 1, 2, 13, 6, any of A through F, let's put in what we know from previous lessons. So we know that vertical angles, or angles that are across from each other, are the same. So 3 and 8 are across from each other, they're the same. 12 and 15 are across from each other, they're the same. Next, we know a linear pair, or angles that share a line like this, are supplementary, or add up to 180 degrees. So angle 4 must be 70, and angle 7 also must be 70. And we'll see the same thing here. So 55 plus something gets us 180. We're going to look here and see that that's going to get us 125. So 4 pieces of information that we can take and basically extrapolate off of what they've already given us. And that's going to put us in a good situation to go forward and solve. If you have any questions on what I just did, I would suggest looking back at some of the Unit 1 videos, specifically about vertical angles and about linear pairs. All right, so first they're asking us for the measure of angle 1, and we have some choices here. I'm going to think, actually, the easiest one is probably going to be corresponding angles. So angle 1 and angle 3 are corresponding angles. Remember, they're on the same side there. So that means that they are supplementary based off of the definitions that we just went through. So because they're supplementary, that means they are congruent. So we can say that the measure of angle 1 is going to be 110 degrees. Let's go to angle 6 now. And again, let's see here. We can use another theorem if we want for this one. So if we want to use the alternate interior angles, the alternate interior angle is going to be 3. And we know based off of that theorem that they are also congruent. So we're going to see that based off of that, it's going to be 110. We could also use the fact that 1 and 6 are vertical. So we know that they're going to be the same. We could also use the corresponding angle, which is angle 8. We know that they're going to be the same. So there's about 8 different ways that we could prove that angle 6 measures 110 degrees. So that's your job as you're working through the rest of A through F here. Just kind of put it together and use those theorems and match up the information that we've already solved for. So based off of what we've just done over here, and I'll highlight it. So based off of these angle measures that we've already solved for, see if you can match the remaining ones. So we have a few more questions to do and see where they match. All right, any questions, let me know. The remaining examples here are just going through other types of applications of a transversal cutting through parallel lines, so the same concept. Hopefully that example number 1 will help you get started. And again, any questions, feel free to reach out.